please join me in welcoming Dr. Wendy Suzuki.
Thank you so much, Dr. Collins, for that wonderful introduction. It is such a pleasure and an honor to be here, to be able to give this talk. And what I wanted to try and do is give you an overview of the different topics that have fascinated me over my career in neuroscience. And the main theme is brain plasticity, which I define as the ability of the external environment to change something in the brain, the anatomy, the physiology, or the function of the brain. And I wanted to start kind of historically. How did I get interested in this topic in the first place? And it really had to do with like for many of us, a professor that oriented me to the wonders of neuroscience. Her name was Marian Diamond at UC Berkeley. Can you tell which one she is? So yes, this is Marian right in the center. And she and her colleagues, including Mark Rosenzweig here, in the late 1950s, early 1960s, were really the first ones to show an example of real brain plasticity. Now, I have to step back in it for a second and remind you that at this time period, late 1950s, early 1960s, all of us know that the brain can change very dynamically in adulthood. But at that time, the idea was there's no change in adult brains. Once you get to adulthood, no change at all, because they didn't have the technology to look at that, to be able to see that. And so what Marian Diamond and her colleagues did was a simple but very elegant experiment, one of the very first ones to show that the adult brain can change. And what they did is they raised rats in what you see here, what they called enriched environments, which is basically like the Disney World of rat cages with lots of other rats and lots of toys to play with. And they compared the brains of these rats to rats that are raised in impoverished environments and showed for the first time changes in cortical thickness, anatomical changes, changes in neurotransmitter levels, and changes in synaptic connections. So this was just fascinating. I learned this the very first day of my freshman year in her class, The Brain and Its Potential, and that really oriented me, really for the rest of my career, to try and understand that level of plasticity at a deeper level. So the classic studies of Scoville and Milner, and later studies, particularly by Brenda Milner and her colleagues, showed that, identified that the hippocampus was critical for memory, but not any form of memory, a very particular form of memory that is generally described as declarative memory, made up of two different forms of memory: episodic memory, that is memory for the episodes or events in our lives, complicated form of memory that includes all the smells and the feelings and the people and the places that are involved in the different episodes of your life, but also semantic memory, memory for facts. Mort Mishkin here at NIH has also called this form of memory cognitive memory. So while Brenda Milner and Scoville and their colleagues were the first to identify this structure, the hippocampus, as key for these key forms of cognitive or declarative memory, actually thousands of years before Scoville and Milner, people already had a very deep understanding of how to strengthen this exact form of memory. And that procedure was called the procedure of memory palaces. When I say ancient, I mean ancient. It was Simonides that has been given the described as originator of this idea way back in 1556 BC. And the idea here was that they developed these approaches to be able to memorize whole sets of things. Remember, this is way before the time of printed books, way before the time of Google that you all know we use our memories for now. And so they really had to have a way to be able to memorize long poems, Bible verses. And the approach that they developed was to picture a spatial location you're very, very familiar with. If you live in a palace, it could be a palace, it could be your house. So start with that very familiar spatial location, and then take a visual or a virtual walk around that spatial location that you know, and then place the new items or the new phrases that you have to remember in a particular order in different spatial locations around the location. And by practicing this technique, you are able to memorize very, very long stretches of things. This form of memorization we know now is very dependent on the medial temporal lobe. And so what I want to do is just end with the implications of this work that really make it so fascinating to me. And the first implication is one of the reasons why I got into the work in first place. So I noticed how much exercise is improving myself. What are the implications for education? What if we integrate in a scientifically rigorous way exercise into education? Well, it turns out that I am at the largest private university in the country, NYU. And this is a picture of NYU's graduation. Yankee Stadium is the only venue large enough for the graduation for all the students and all the parents. So we've started a pilot program with freshmen looking at the effects of one semester on exercise, one semester off exercise, to try and take advantage of the resources that I have and look at the effects of exercise, not only on the cognitive functions that I've been talking about, but on study habits, drug use, even academic performance. And so those studies are in the middle right now. As I mentioned, aging, critical issue, and we are applying to NIA for some of these grants to look at the effects of exercise in a younger and an older population to start to see whether there are differences and sensitive periods across the aging before you get up to 65 or 70 years old. And finally, neurological disease states. We're particularly interested in ADHD and autism. And we've actually done work in traumatic brain injury. So all of these kind of aspirational kinds of questions. So this was the full adventure in brain plasticity from memory palaces to soul cycle. And I just want to end with a very practical note, because at the end of my talks, everybody says, okay, that's fine, Wendy, but just tell me how much I have to exercise. But just give me the formula. Actually, and then they say, oh, wait a second, tell me the least amount of exercise that I have to do to get any of those effects that you have. And so the good news is that it looks like you don't have to become a triathlete to get these effects. But on the other hand, if you're a walker, that's great. Walking is great, but you're not going to get all of the benefits. So something in between walking and being a triathlete. And I think the exciting thing is, sorry, that's a little bit vague, but that's where we are. And I think the exciting thing is that these different cognitive functions are going to have different formulas. So we already know that mood is improved by simple walking. It's also improved by aerobic exercise, but you can get that with simple walking. I don't think you can get the hippocampal effects with just walking. And I'm not sure what the minimum level or the range of the optimal level is for the attentional effects that would be beneficial not only to students, but to researchers working in the lab, as well as to the aging population, given the age-dependent effects on both prefrontal function and hippocampal function. So with that, I would be happy to answer any questions, and I thank you for your attention.